As we'll see in upcoming chapters, when we use control charts, it's very important that our data follow a normal distribution, and if they don't, we need to figure out what other kind of distribution could we use in order to make those data more normal-like. And a very common way of transforming your data is to log it. But before we get to the logging part, we need to first of all decide if data follow a normal distribution or not. Now, we've got some data here, time to failure, and if we simply did, if I went into my basic statistics, display descriptive statistics, chose my data, and went to graphs, I could choose a histogram and a box plot, say OK and OK. And I've got issues. When I look at my histogram, this is extremely right skewed. A very long tail to the right and no tail to the left. So these are highly skewed. And by the way, when you see data that look like this, where there's a high, very high on the left-hand side of the graph, and then it gets a long tail to the right, that usually indicates data are what we would refer to as log normal. In other words, if we took the logs of the data, we would make them follow a more normal distribution. And when I look at my box plot, there are 1, 2, 3, 4, 5, 6, at least 6 high outliers. So most of my data fall between the bottom whisker and this point right here. What is that? Q3 is 262. But there's some very high values up here. What's the highest one here? 1,524. And the one at the 75th percentile is only 262. So that tells me, again, I'm not dealing with normally distributed data. Now, in order to find out whether or not log transformation would work, we would need to log the data first of all. Now, you don't have to do this, but I normally do. I'm going to create a column header that has log of time. And you can use natural log or log base 10. It won't make any difference. Generally speaking, in engineering purposes anyway, we would use natural log. If this was biological data, we might use the log base 10, LOG, but it won't make any difference which one we use. Now, in order to log these data, I'm going to use my calculator function. And a calculator function in Minitab is a little bit weird. Doesn't quite look like a calculator. So the first thing that you have to tell it is, whatever you want it to do with your data, you got to tell it where to store the result. And I've already created a column there called natural log of time, which I could choose here, or I could just type in C25. So that's where I want the answer to go. Now, the expression. What do I want it to do? I want it to take the natural log of all the numbers that are in column C4. And if you scroll down in this list, which is alphabetical, you will find, where is it? You will find natural log, log base E. I say select to this. And really what it's done here is there's a mathematical expression. And I can take the natural log of a single number and plug in the number where the word number is here. But, well, that's way too much work because I want the program to take the natural log of all the numbers that are in column C24. So I'm just replacing the word number by the column number, which is C24. So it's going to take natural log of everything in C24, stick it in column C25. Say OK to that. And here I have it now. These are the natural log numbers. And if I went back up here into my basic statistics tab, display my descriptive stats, and this time I choose the log of the time data. And I've already got my graphs turned on, so that's okay. Say OK to this. Now I get a box plot for which those outliers have disappeared. This box plot looks fairly symmetric. Yeah, the little bottom piece here and the bottom whisker is a tad longer than the top. But overall, these data are pretty symmetric. And when I look at my histogram, I got a high point in the middle, spills out to the right, and spills out pretty much an equal amount on the left-hand side. So by taking the natural log of these data, I've made them follow a more normal distribution, and then I could use them for subsequent charting.